Okay, so in this video, you're going to do the next step, which is learning how to name ionic compounds from their ionic formula. So the opposite to the last video. Naming ionic compounds is extremely simple, and you just have to follow some simple rules. The first thing is to name the metal first. So when we're naming them, instead of writing oxide sodium, we write sodium oxide. The second thing is to name the non-metal second, and then importantly, if it's an element, change that ending to an "ide". When we have polyatomic ions, like sulfate or carbonate, we don't change their endings because that would change the identity of the polyatomic ion, so we just leave those. So two examples would be sodium oxide, which is simply the name for this formula here. So we write sodium and then we write oxide. We don't have to worry about the subscripts because they're implied by the charges which we know from sodium and oxide. So if you were to convert this back into an ionic formula, you would know that it would have these subscripts because you know the charges on sodium and oxide. The second example is MgCl2, and that is simply named magnesium chloride. So you ignore the subscript, it's just magnesium and a chloride ion afterwards. Importantly, we changed the ending of chlorine to chloride. So the next examples are polyatomic ions, and in these cases, because they're polyatomic ions, we don't change the endings. So here we have CaCO3. CO3 is a polyatomic ion, and you should know that that polyatomic ion is carbonate. So when we write this, we simply write calcium carbonate. This one here, magnesium Mg, and then SO4, we should identify that this polyatomic ion is sulfate. So we simply write magnesium first, followed by sulfate, magnesium sulfate. The final little bit of information that you need to know in order to write ionic compounds names well is that when the metal can take multiple charges, we give Roman numerals to identify which charge the metal has. So if a metal can take two charges, you need to show which one it is by using the Roman numerals in brackets following the metal's name. So for example, FeO, we know that this is Fe, it's iron, and we know that O is oxide, and we can derive the charge on the metal from the ionic formula. Because oxide has a -2 charge, and we know there is only one Fe here, that means that the Fe must have a +2 charge. So this would be written iron to oxide. The next example shows another charge of iron. We can see that because there is not, if there is oxide we know has a -2 charge, and if there are 3 of those in total, there is a -6 charge in the ionic compound. That needs to be balanced by the charge on the ion. We know there are 2 ions, so we can go, what can I times by 2 to make 6? The answer is 3, so this must be iron 3 oxide. Let's have a go at some of these as a class. So the first example we're going to do is KCl. We can identify that K is potassium and Cl is simply chloride. The second example is K2S, that is potassium again, and The S stands for sulfide. This example here is one of those transition metals which has multiple charges. We can see that it's CuO. We know that O has a -2 charge, so this copper must have a +2 charge. Therefore, it is CO, copper 2 oxide. This example here of SnCO3, we identify Sn as tin, and CO3 we should know as carbonate. On this side, we have Cu2O. So in this case, we know that the O has a charge of -2, and from this we can infer that the copper must have a +1 charge because it requires 2 of them to balance out the -2 charge from the oxygen, and therefore it is copper 1 oxide. The next example is Fe2O3. So Fe2O3 would be iron oxide, and we have to describe the charge that the iron has. So we know that the oxide has a -2 charge. We're timesing that by 3 to make a total of -6. We have to balance that -6 out with the charge on the iron. We have 2 ions to make a total of 6, therefore it must be iron 3 oxide. The next example is NH4SO4. So NH4 is ammonium, that's a polyatomic ion, and we have another polyatomic ion of sulfate. So this would be called ammonium sulfate. The final example has SnPO4. So in this case we have tin phosphate. So we have to infer the charge on the tin in this case. So if phosphate has a 3- charge, and there's 2 of them, there's a total of 6, and therefore the tin which there is 3 of must have a +2 charge. So this is tin 2 phosphate. Let's go back to this one now because I've realized I've made a mistake. We need to identify the charge of the tin in this one as well. We know that the carbonate is CO3 2-, and therefore this must also be tin 2 because they've bonded together in a 1-to-1 ratio. Now there are many examples of naming ionic compounds from their ionic formula and writing the ionic formula from the names of ionic compounds in your chemistry booklets. They are on page 29, 31 and 32. I'd like you to complete them by homework for next week on Wednesday. That's plenty of time to do this work, and if you don't complete it then I'll give you a red stamp. Okay, thank you for listening.